Holger will talk about security in HPC with containers.
So, all right, everyone. So I'm basically the last one standing between you and your evening. So this is going to be more like of a lightning talk. And my idea was to link the two workshops, the one regarding containers and this one regarding security with the topic on how to improve the security in HPC with containers. Because from my perspective, containers are not really something to be afraid of anymore. And so a bit more me, I'm Holger, I'm with Science and Computing since 2009 and got a degree in computer science at the only university with 2 winter semesters, which is called Furtwang. And for a large portion of my day, I'm a senior systems engineer rooted in the delivery and working with customers from the field of automotive CAE. And as I said before, I'm highly interested in everything that is virtualized, mainly Linux desktop infrastructure, but also using container technology in HPC and everything that has to do with HPC in the cloud. And yes, as I said, I'm working for S&C. We now belong to Atos, and enough of that. Let's get to the topic. And so the first thing I want to talk about is what we see from a more enterprisey point of view, what our customers are going for, and what trends we are currently seeing with regards to HPC security, and how, as a second part, how containers can support these trends. And another thing which gave me a bit of lack of sleep over the last couple of days are topics like a software bill of material. Probably everybody is suffering from the same issue right now, and then a brief summary and conclusions, and hopefully time for some questions. So what we see in trends related to HPC security, what our customers want. I mean, as we saw in this workshop, there's lots of stuff one can do to secure the perimeter of an HPC system using VPN to ensure that only the trusted users can access the site using SSH keys, or even way better using two-factor authentication, exposing only the login nodes and having this separation of concern here. But anyway, once the user has reached the system, he is more or less a great liberty in regards of what he can do with the HPC environment. So from our point of view, we see that users want to run ISV codes, that we have some admin installed applications, and also the users supported or provided applications, usually residing in his very own binary directory in his home. And as I guess for research-oriented infrastructure, this is even more thing than I have with my automotive customers right now. And one thing to keep in mind is that the HPC environment is not really the typical regular enterprise environment. And this is what makes security there especially interesting. And it's sometimes quite hard to explain this to outsiders. I witnessed this at FOSDEM in 2017, where one of the Singularity developers introduced to the audience at the Linux containers, and I think it was microservices dev room, how Singularity works, and that they have this portion that requires a set UID for privilege escalation. And then there was this one guy in the room who was later giving a talk on C groups v2, and he was quite struck by lightning, and he was really looking confused, and it needed like I think 4 or 5 people to convince them that is really that's the case how HPC works, that users can bring along their own application, and that it's not all curated by admins or whatsoever. And and that the final goal to punish someone was basically banning him the access from the HPC system, and without the access to the HPC system, he can't do any simulations, and this means no publication, and this means basically the end of his research in academia, and the end of his career. So this might, speaking to outsiders, which is not necessarily the case here, but for someone not familiar with HPC, that great liberty and the trust that is usually provided in the users is quite something to talk about. So enterprise HPC environments currently move towards the direction of more putting zero trust inside the networks, basically distrusting everything. And they are also looking into turning their HPC environments into some sort of multi-tenancy isolated environment, granting access for external partners, but also sometimes to a level of competition. Let's call it competition, not necessarily Daimler and BMW, but other companies they might consider competition here. And also the aspect of having to support the future workloads, say AI and machine learning and data analytics, and probably also other entities inside the company, and having this idea of having one large block of big cluster used for everything is what is driving some customers in rethinking the way they are doing HPC. And also another thing is they want to use grid-like multi-site infrastructures and also moving to the cloud. So this implies to a certain degree that there's a certain necessity in the ways things are done, and containers can be of help here and can also improve the security here. So containers can support these trends. Just a quick recap from the last workshop on, I think it was Monday. Why researchers love containers. Containers to a certain extent provide them the mobility and portability they want when moving their code from the laptop or the workstation to an HPC system, and sometimes also in the cloud, and having this encapsulated software environment that has all the libraries and dependencies they need for the application to work, and getting this to run somewhere else. And also they like the idea of the user provided applications resolving their dependency conflicts, and solving this dragging works on my machine issue. And I think it was on Monday I spoke to a cluster somewhere in the Nordic area where they said, okay, we have this user who is running some legacy Fortran code that is only running on Fortran on CentOS 5. They, for example, are operating this in a containerized fashion. And also what is driving containers in HPC is the scientific collaboration and aspects that you can provide possibilities for an unprivileged build here. So another thing is the reproducibility, that it's easy to share with other research institutes your code, what you're working on, or making your application basically part of your publication, saying, okay, here's my data, this is what I did with it, and this is the whole software stack that went with it. And obviously, the performance is important in HPC, and as backed by several studies, it's quite close to bare minimum overhead that is introduced by containers. So everybody wants containers, and as we learned before, security is quite important. Back in the day, when the whole trend around Docker started, everybody was a bit panicking around the security of containers, and especially in regards to Docker. This was what basically started the whole trend of containers, of HPC specialized container runtimes. So over the time, the security issues or what security features are provided have changed quite a bit. For example, you can use fancy stuff like SecComp profiles for your containerized application, which allow you some sort of basic sandbox that only allow you to use a certain amount of system calls. You have the traditional features, control groups and namespaces, which provide you, or which limit the resources the container can use, and also provide this limited view of a system here. And SE Linux is also supported, even though it is typically turned off in HPC. And what Tim also might like, it integrates usually quite well with the Linux auditing system. So from a security point of view, what you can apply to your container runtimes and containerized workload is quite good. What we have, or what we see now compared to say 5 years ago, and also with features like rootless containers or relying on user namespaces, this is greatly improved. And also in regards of what you can do with security monitoring, focusing on the containerized workloads, there are nice things that are possible here. So the key takeaway: container technology has matured over time. And it's not necessarily dreaded anymore that people run containers. I mean, the whole Docker shocker time or features that you, if you grant a user access to the Docker CLI as a mean for privilege escalation, are more or less a thing of the past if you use the well-suited container runtime here. And as I said before, we see the rise of security features that are supported. So, for example, taking or returning to SecComp, and the idea of sandboxing a workload. This is something really nice, which could be probably also, at least to a certain degree, be automated, that you generate, or you have a training phase of your application you want to use and say, okay, this application uses this list of system calls, and then basically just ban everything else that it's not needed. This would be or could be something to implement here. And typically using containers does not mean granting a user necessarily more privileges than he would actually have on the system. So for example, Singularity has the rule that you can only be root inside the container if you are root on the host system. And beyond that, containers provide the possibility to resync, basically the whole HPC system software stack. There's a nice paper from Alan and some others called Modernizing the HPC System Software Stack that go full containerized and provide this idea that you only have your bare minimum installed on your system. So basically what you need to get the system running, and then having everything else you want to run on the system in a containerized fashion. So this might be something, at least for some use cases, worth thinking about. And from my understanding, the idea of containerizing all the things is quite tempting. And one aspect is having this software bill of material. So also, answering the question of what is running on my cluster. So nowadays it's quite hard to keep track of the software you use on a large-scale system, especially if the users are granted the possibility to bring along their own application and bring along own further dependencies for the workload. And at least containers don't necessarily make this go away, but it provides you means to be able to check this more easily. So, and this gets, or having this overview gets especially hard when the software is provided with some other means than RPM or your typical package manager. And it's also hard to answer questions like what software is outdated, needs some update, or has vulnerabilities, especially important these days. And or more from a scientific point of view, what software uses a buggy library version that may impact my results of my simulation. So answering these questions gets much easier when you rely on containers as sole source of software deployed in your environment. So basically, it goes to this equation that the software uses is your host software and the container image content. And there are some open source software solutions that support this idea and can help you come up with a bill of material and also check for, say, licenses your application use, or even going that far that they provide you checksums of all the files inside your container, so that you can easily compare this to a new version. And if you think about doing something, this list generation should be implemented quite early in your release process of a containerized application, and also be integrated in your application in your container registry. So why is this important? I mean, most people probably have seen this nice XKCD, and that there's this super tiny piece of software, and that basically puts the internet on fire, also known as Log4j. And we are quite busy these days, at least I am, as finding out where all this little piece of software that is super annoying is implemented in all stuff. For example, we have VMware Horizon setups that relies on this, but we might also have some CE application that is using this because it uses Java. So we, alongside some other groups, have to do quite a bit of digging these days and finding out, where we use this. And if it's not Log4j today, it might be something else today. So even the NSA came to the conclusion that a software bill of material would be highly interesting. And as I said before, there are tools that support this idea. I just want to show two of them. One is called ZIFT, which basically generates or scans your container images, and to discover all the libraries you have installed. They can rely on APK, the Debian package manager, the RPM, and basically everything that you have on your system that can bring along some library or some dependency. And by this, you can quite easily check your what is contained inside your container image. And in this case, this was a deliberately old one. It is quite vulnerable for some, for this Log4j thing. And this can also then be combined with a vulnerability scanner. In this case, I use Scribe to just scan this very image. If my image is vulnerable, and as expected it is, and it refers to this quite critical incident here. So coming to a summary and conclusion, containers have come quite a long way, and I mean, containers are not just Docker anymore, and we have, especially in HPC, quite a variety to choose from, say Singularity, Charlie Cloud, Zaros, or on some sides even Podman. Which is a bit more enterprisey than say Singularity. And we see a high level of acceptance in HPC environments, even up to 80% on some sites. This was somewhere in the Nordic environment as well. And it is loved by users because it might simplify the way how they bring the software inside the environment. And containers can support these trends, and provide also possibilities to rethink the application deployment, and make sure that only certain audited or whatever security checked software might be running on your site. And what it definitely will bring is it will improve the insights regarding the software you're running on your system. The downside is that having gained this knowledge, what is running on your system, you might have to decide what to do with it. Say, having some guideline. We will only reuse images that are do not contain any critical issues or whatsoever, or run this on a different version of the system. But at least you know before, and this can bump up your level of security to a certain extent. So that's it from me. Are there any questions?
Yeah, thank you. John raised his hand.
Coincidentally, one of my colleagues, in fact, ran gripe on a Singularity container that one of our users would like access to just yesterday, and obviously it came up with a bunch of stuff, and so now we're stuck with this, as you say, rather philosophical question: we know this container image contains vulnerabilities. We've actually no idea whether any of the code uses it because he's shipped a whole full, it's not one of our users who's created the image. It's got a whole Ubuntu operating system inside it, essentially, most of which probably isn't touched. Do you have any good thoughts about how one makes that judgment as to, do I as a systems administrator say no, which, as you say, genuinely stops a scientist doing some work and hence having a career? Where do I draw the line? Obviously, you've given the example of, has it got a critical vulnerability? Yeah. The chances are these days, if it was built more than 3 months ago, it's got a critical vulnerability in it.
Yeah, I honestly haven't found the silver bullet to ditch this. I mean, it's especially when you're dealing with this legacy code, say this Fortran on CentOS 5, you obviously will run into some issues. But usually, if you're not, say, running Docker in your most vulnerable way you can run it, the user shouldn't be granted more privileges than he actually has on the system if he wasn't using containers. But
yes.
Anyway, I would still make sure what some say a sort of vulnerability scanner says about the image, and then maybe look into what can be done to mitigate this. I mean, does he have, say, the build instruction for this thing, his Docker file or Singularity definition file, and see if you can change the lower levels of his setup and just update it to a more current version, or if, yeah, will this break his application?
But will it break? We don't know. We've got no idea. And the whole, as you say, one of the great advantages of going with these container images is you get a well, you don't get a promise or anything in the academic world. Obviously, you get a, well, this particular config worked for us from someone else. And this is coming in from a different lab. And so as soon as we touch that, we start to break even that feeble, this once worked. Because we've partly, as I say, because we're not really sure what bits of code actually do get touched. And that's really hard. Because again, if we were to move, and we are kind of doing so, move in a more, well, actually, we need to keep a record of which particular version of a bit of software we ran. That does mean that for some time we are going to have to be running code we know to be insecure, because we've got to run, because the update isn't available.
No,
but we know it's insecure.
How are you dealing with this right now? Are you
Badly
running it anyway, or do you have like a spare part of your cluster that has some, say, additional security monitoring in place, or whatever?
At the moment, we are generally, where containers are concerned, we've built them ourselves, and so we know we've pulled down a fresh version of whatever the underlying operating system is. And as I said, I'm surprised that they tend to come with an entire OS install within them, because my understanding is that actually you could strip out everything except the libraries that it actually requires. Yeah. And it'll all work fine.
Start with
but that's not what people do.
With a tiny Alpine or whatever.
Yeah,
it was funny because as I was doing this bill of material thing yesterday, and I was doing this with an Alpine, and it was just like 5 lines or something like that. And I used this logstaff thing, and I just had to grab and filter and stuff. And so if I was granted the liberty to do this on my own, I would probably start with a very tiny base OS and look for users to provide them this base layer where they put then their application on top.
Okay. And finally, it's pure coincidence, I think, that we ended up with ZIFT and Gripe. This is not a space into which we have stepped before. Would you say that is one of the better applications in that particular space? Is it the only one? It was Gripe and ZIFT, as you were talking about.
I used Claire before. but
Right.
I just noticed that these are new, and I wanted to try them out, and they seem to support more than more package managers than Claire did before.
Cool.
That's why I went with these, but I think Claire should also work.
Excellent. Thank you. Very interesting.
You're welcome.
Some more questions?
Yeah, but final word from myself. I expect that we are going to see containers more like something that is installed on every HPC system. Just speaking from the demand we see, and especially, I guess, for the researchers and less our automotive customers, where they can rely on their admins to install them the latest version and just bug them about this. I see it's a very nice tool for scientific users, and I think in a couple of years it will be just everywhere, and we won't necessarily talk about having users run their own code from their home directory.
If I can pop in another question. So that touches on something that I've also been thinking about. Obviously, using something like Singularity, you do get some additional protection against privilege escalation.
Mm-hmm.
So are you saying you think it will become normal? Say, I mean, we use a batch scheduler, we use Univer, we're probably going to change to Slurm for financial reasons. For instead of the scheduler, the execd actually just running the job, it will instead instantiate or start a generic container and run the job within that generic container, just attaching the file system to wherever the job thinks it ought to be attached to and things like that.
By generic container, you mean like a really generic container, or
I mean a container that simply is an operating system. It is essentially my compute image for my work interface.
So basically, like LXC was doing ages before Docker, but
yes.
Nobody speaks about it anymore.
Yes, exactly.
Yeah, I mean, IT comes in waves. Now we are moving. We moved from containerized operating system or virtualization at the operating system level to containerized applications. So it would only be logical to go back again, but I'm not sure. I personally like the idea of having this specialized piece for one application, but who knows? I've seen customers demand like a full-fledged image of everything they have on their workstation, so that they can basically carry this around as a container image. But this is quite painful to maintain because you have changes all the time. But I mean, that's what they ask for.
Yeah, and as we discussed earlier, I do find it surprising that there's so much inside every container I've looked at.
So, John, if you have any more questions, feel free to say hi to me.
And of course, everyone else, I guess.
Obviously. I was just referring to John because he was the most active.
Yeah, thank you for the presentation. It was also quite nice.